He's one of the leading volcanologists. He is a professor at Uppsala, I believe I said that correctly, Uppsala University in Sweden, previously Trinity College in Dublin. And I have a cheat sheet for this final one. He has a fellowship of the Royal Society of Arts, is a membership of the Royal Academy of Sciences in the Canary Islands, and a fellowship of the Royal Geographical Society. So he really knows his stuff, ladies and gentlemen. So it gives me great pleasure to introduce to you the fantastic Professor Valentin Troll. Here we go.
Thank you so much, Robert, for the kind words. And yeah, it's a great pleasure being back on Seaborn and to speak to you all tonight. And yes, as Robert said, I'm working on volcanoes. That's what I do. And it's volcanoes every day of the week for me normally, and all sorts of aspects to do with volcanoes. I started working in the Canary Islands well over 20 years ago, and I've been working there ever since. I've published on all the individual islands, and this is what I'm going to do today. I'm going to start by introducing each of the individual islands to you. Each has a slightly different character than the other ones, and after that we're going to go through some of the geological highlights of the Canary Islands. If there is something that might not be entirely clear, please do feel free to get in touch with me after the lecture or somewhere on the ship. If you have a question, feel free to approach me. I'd be more than happy to answer all the questions that are thrown at me. So we are going to the Canary Islands. We are now in Morocco, and we're gonna move. Let's see. The pointer has given up on me. So, but anyway, we're gonna move down the West African seaboard towards the Canary Islands. Tomorrow we're going to be in Casablanca, and then we're going to go to Lanzarote. And the Canary Islands have been a major landmark for sailors for hundreds of years, and this goes back to this old Dutch drawing from the 1600s, and it shows Teide volcano. It's a little oversteepened, I guess, but you get the idea. The important information here was that Teide volcano was so tall, it stuck through the clouds. And you could see it above the clouds from a far distance. And this was the vital information this image actually portrayed. And then we have a drawing from the 1790s in the top right. This was one of the eruptions observed by early scientists. And then we have one of the early postcards in the bottom right, which shows the Orotava landslide valley, a giant landslide valley, and Teide volcano towering over the valley. So the islands are a string of islands, it's a chain of islands, and there's this big discussion: has there been a land bridge between the islands, or are they independent edifices? And I can tell you straight away, they are independent edifices. There is no land bridge that we know of, and you can see that when you look at the ocean floor bathymetry. This is where we can map the ocean floor, and there is no connection between the islands. The islands are isolated edifices. In fact, the islands are only to a small proportion above sea level. Most of the islands is under the water. So this is the island of Gran Canaria, one of the taller islands, and there less than 5% of the island is actually above sea level. The rest is below sea level. So most of the island is pretty inaccessible to us. So the edifices grow from the ocean floor, and that is about 4,000 meters steep, and they grow up to 3,000–4,000 meters, depending on. So some of them are 7,000 meters tall, and that makes them amongst the tallest volcanoes on the planet. The only taller one out there is actually Hawaii. So the Canaries are in competition, and Hawaii still kind of leads the race here. So we have all of these little islands being separate entities, and there is an age progression, and we'll come back to this a little later. But let me introduce you to the individual islands first. We will not visit all of the islands on this cruise, but we'll see some of them, and I wouldn't want to miss to give you a flavor of their individual character. So the island of Fuerteventura, it is Well, a pretty flat island. The highest elevation is just about 800 meters, and the population is a little over 116,000 people, and it has a population density of about 70 people per square kilometer. Does anyone have an idea what the population density of the UK or Germany would be? One of the main European countries? About 240. So where I come from in Sweden, the population density is a little lower, it's 24. So here we are somewhere in between what would be Sweden or the UK with 70 people per square kilometer. One of the key features of Fuerteventura is it has a lot of beaches, and really white beaches. And this has been a geological puzzle until we started to understand satellite imagery a little better. And there we actually have a lot of sand blown over from Morocco that is deposited on the islands, and particularly on Fuerteventura. And actually the sand, the dust, it blows even further out on the Atlantic. And if you have a dusty day in Florida, it's actually also coming from the Sahara. So it's traveling all over the Atlantic. And it actually is a very good nutrient, even for the Amazon rainforest, where some of the dust will settle as well. So where we've been today and where we're going to be tomorrow here in Morocco, I'll try this once more. Ah, now it works. Wonderful. So here you can just about see the outline where the arrow is of the Moroccan coast, and this is where the Canary Islands are, and you can see the sand from the vast Sahara being blown over out onto the Atlantic, and the images on the right-hand side are the sand deposits, air-blown sand on the island of Fuerteventura. So the islands are pretty flat, they're pretty old, as I said, and they're very desert-like. The other island, just a little north, is Lanzarote, and it is, well, also very flat, 670 meters of elevation. Population is about 150,000, and the population density is a little higher, more people on the island per square meter, and we have about 180 people per square kilometer on the island. The island is famous for several landmarks, and one of them is the Timanfaya National Park. And we're going to be there in a few days. If you have an opportunity, I recommend it very highly. So here we have the lava fields in the top right of the Timanfaya National Park. And this goes back to a large eruption in 1730 to 36. And some of the volcanic craters, they're now opened up by coastal erosion. And for example, down here, the El Golfo crater, there you can actually walk. It's a beautiful hike. And here's another little crater that has now been transformed into a salina, a salt production place, where water is let in and then the water can evaporate and it produces a lot of salt. You can visit there as well, and you can even buy a souvenir pack of salt if you're interested. So another famous feature of the island is the way the wine is grown. Prior to the 1730 eruption, there was very little agriculture on the island. And during the 1730 eruption, local people realized that a sprinkle of volcanic ash is really good for the soil. And after the volcanic crisis, suddenly they used this idea all over the island, and they could grow a lot of crops and a lot of vegetables, and they also started to grow wine. But the island is very flat, and the wind is very strong. So they had to build little walls around their plants, and this is what we see here. It comes from the valley of Lageria, and so it's called the Lageria way of making wine, where the plant is actually very low down. It's in a little hollow, and there's a small wall around it, and it sits in volcanic ash, and that's very good. It gives a lot of nutrients, and it can keep a lot of moisture. So the Timanfaya National Park, it's the second largest national park in the Canary Island, and it's the heartland of the 1730 to 36 eruption. So here you get some impressions. It's a lava landscape or an area which are covered with volcanic materials. And yeah, there you see wonderful features, but I'll talk a little bit more about this in some of the future lectures. Let's move on to some of the other island, and that is Gran Canaria. We will not visit, unfortunately, but this is one of the largest islands. This also hosts the government of the Eastern Canary Islands, and it has a population of 850,000 people and a population density of 545. So now we're well above the population density of normal European countries. So this is a very densely populated island. So here's a geological map. And well, the good thing about geological maps is colors mean different ages and different rock types. And the green ones are the very youngest rocks, and the blue ones are the very oldest, and the red ones are in between. And there we can see how the island built up with time, and the current active volcanism is actually in the northeast of the island, as it happens round about the capital area of La Palma. And well, the problem is the last eruption there occurred about 1,900 years ago, and the Aboriginal people did witness the eruption because we found tools caught up in ash from the eruption. So if this type of eruption would happen today, it would be rather unpleasant next to a major population center. So here's a few impressions, and in the top right we have the city of Las Palmas, and on the left we have a small volcano in the northwest of the island. The people from Gran Canaria are a little jealous, I think, because they don't have a big volcano like Teide, so they call this Little Teide because it's got a perfect shape, but it's much smaller. And then we have a Grand Canyon-like landscape in the southern part of the island, and in the center of the island we have a monument that was worshipped by the Guanches, the Aboriginal people, and that's the Rocanublo monolith. It stands very proud, and it was worshipped by the Aboriginal people. Gran Canaria actually has a host of archaeological sites as well, and here we have various ones. And these little caves there, they were apparently used and dug to serve as a grain store. And there's a hill fortress on the left. There was also a battle between the Spaniards and the Aboriginal people. And actually, initial successes on the side of the Aboriginals were very much, well, forming substance in the literature. But ultimately, the Spaniards did succeed and suppressed the local population. So this is the little volcano in the north of the island, and it's called Caldera de Bandama, and this erupted about 1,900 years ago. It's very close to the capital, and it actually is very good for making wine. And you can also just about see up there, there's a golf course now. So right now, it's a very calm volcano. Hopefully, it will not wake up again, but it reminds the geologists what would happen if, and that's a good exercise. So as I said, Gran Canaria is very rich in archaeological finds, and if you ever have a chance, I recommend it highly. But we are not going to Gran Canaria yet. We're going to Tenerife. And Tenerife is the capital island of the Western Canary Islands, and it's got a population of 917,000 people, and the population density, however, is a little lower, 444, and it's the tallest point in all of Spain, with Teide volcano reaching 3,718 meters above sea level. So here's Teide volcano, and as the Dutch drawing I showed at the very beginning was trying to bring across, Teide sticks out above the clouds, and that makes it a landmark that can be seen from a far distance. Teide also sits in the national park, and the national park is an area in the center of the island, and there we have well, protected species, we have protected landscapes, protected flowers, and you can go and visit, it's accessible, but you're not allowed to obviously take any samples, be it rocks, be it plants, and there Teide sits in the middle of it, and right next to it is this intriguing feature. It's called the Tree of Rock, and it happens to be the most photographed rock in all of Tenerife. So this is really a popular rock, and well, I guess you get the idea. It's because it's very, very thin down here in the bottom part, and there was a similar rock on Gran Canaria. It was called the Finger of God, and in a stormy night, the Finger of God fell over. And ultimately, this will be the same fate. The tree of rock will fall over one day. It's just erosion. But there was a proposal by the local people to put the Finger of God back up and stick it together. And of course, the geologists did not think it was that smart an idea. And indeed, the Finger of God is still lying there in pieces. It's not going to be resurrected. So let's see about this one when it comes to it. The volcano, Teide volcano, is the youngest feature on the island. It sits in the Las Cañadas caldera, a big collapsed caldera, very similar to Yellowstone, for example. Maybe not quite the same size, but the structure is very similar. And you see the caldera wall there in the distance. And just in the far distance on that photograph on the horizon, you see the shield shape of the island of Gran Canaria. You can actually go up to Teide, and there's a cable car station that brings you up there. It is reasonably affordable, so if you're adventurous, it's a very interesting thing to do. You can go up there if the wind is not too stormy, and it brings you all the way up to about here, where the arrow is. Sorry, whoops, bit hard to get that. It brings you up to here. Not quite to the very peak, but almost to the peak. It brings you up to 3,500 meters. That's actually exactly the level where altitude sickness kicks in. So if you're a little susceptible to altitude sickness, go easy. But otherwise, it's an adventurous trip. So the next island I'd like to introduce is La Gomera. And La Gomera is actually the least volcanically active island in the archipelago. And it's deeply eroded because of that. It's not getting refilled by new volcanic material, so erosion carves these spectacular valleys. There is one place in the north of the island, it's called Los Órganos, the organs, and this is a intrusion, a former volcanic neck fill, and it's cooled to make these beautiful columns. Very similar to, for example, the Giant's Causeway in Northern Ireland. The population density of the island, however, is very low, 58, and population is only just about a little over 20,000 people. The elevation, however, reaches still about 1,500 meters, and it hosts a very old forest in the center of the island. That's the national park on La Gomera, and if you have an opportunity to go there, it's beautiful up there, and you can just about get the idea of the rainforest in the center of the island on the image to the lower left. So here's a few impressions of the Los Órganos situation. We don't have to go into the details of the geology, but there these columns form when magma actually cools, it contracts, and then you get cracks. It's like mud that starts to dry up, then you get little cracks, and they're polygonal cracks. And this has all to do with intrusions inside volcanoes, and some of these big rockets that stand out on La Gomera, they were worshipped by the Guanche people, the Aboriginal people, but the geologists, of course, trying to reconstruct how they formed in the first place. One of the small islands, El Hierro, is one of them we will not visit, so I don't want to spend too much time there. Again, it's also about 1,500 meters tall, 10,000 people, or just about 11,000 people. Population density is only 40. And there is one famous thing about, actually two famous things about El Hierro. One is the hydropower plant. It's been pioneering, and it's a new model for the islands here. What happens is that the wind is used to pump water up the hill, and there it's stored in a volcanic crater. And when the weather is not fortunate enough, then you can just open the tap and the water runs down, and you make hydro energy. And then once the water is downhill, the wind that blows will pump it up again. So it's almost self-sufficient. And this is a big idea that now hopefully gets transferred to the other islands as well. Water is very important on El Hierro, and it goes back to the Guanche people. There is the Garoe, the holy tree of the Guanches. And it's been famous because it's supposedly a magic tree that can produce water, that can rain. Well, it's a little more complicated. What happened was the conquistadores pushed the local people, the Aboriginal people, up into the mountains, hoping they would have no resources there. But the winds coming from the Atlantic, they're very moist. And some of the trees will actually start to capture the dew. And if the dew drips down and there's a substrate that doesn't allow the water to, well, filter away, you actually get little ponds. And that was what the Guanche people used. And there we had this tree that was supposedly raining, but it was really just coming from the clouds. And then in these local water ponds, they collected it. But this is where the legend of the holy tree, the Garoe, comes from. The most volcanically active island in the entire archipelago is La Palma. La Palma hosted about more than half of all the eruptions in the historical record, and the big one was in 2021, and I'll have a separate lecture about the 2021 eruption when we are on La Palma. So La Palma has an old volcanic shield, the Taburiente shield in the north, and a new ridge that's growing and it's continuing underwater. It's called the Cumbre Vieja Ridge. And the Cumbre Vieja Ridge is pockmarked with volcanic cones, and this is where all the historical eruptions occurred. And we have quite a record of them. So here on the little map on the right, you see the historical eruptions. In the top left, there's a photo from the 1949 eruption. The top middle one is the 1971 eruption. And the top right is a night view of the 2021 eruption. The image in the bottom is a view towards the old shield volcano from the active part of the island, volcanically active part of the island. The old part is now extinct, so if you want to buy a property on La Palma, I recommend the northern part. So the eruption, as I said, was a big eruption, and it led to the displacement of more than 8,000 people and damages on the order of €1 billion. So that has been a bit of a disaster, but as I said, we'll talk more about this when we are on La Palma. So I'd like to spend a little bit of time now to explore how the volcanoes of the Canary Islands actually form. And I told you that the islands are all a little different. They're not quite the same. And this is because they're all of different age. So here, looking from the west towards the Canary Islands and draining all the water away, so you see Tenerife, you see La Gomera, and the small islands of El Hierro and La Palma. And there's a tiny little seamount, a submarine volcano that's growing now. It's called Las Hijas, and maybe this might become the next Canary Island when it's grown properly to full size. What we realize when we look at the Canary Islands is that there seems to be an age progression in terms of shape. The young islands with a lot of volcanic activity are in the western part of the archipelago, and then the big islands, the large ones, are in the central part, and the flat islands are in the eastern part. And that gives us an idea about the age. Obviously, the longer the island is around, the more erosion happens, meaning the flat islands are a lot older than the younger and steeper islands in the west. So the archipelago has 7 main islands. Some people will tell you it's got 8 islands because there's the island of La Graciosa, which is a bit of a debated thing. La Graciosa is a funny little island off Lanzarote, and not a lot of people live there, but it was actually the island that inspired writers to talk about treasure islands, because apparently there's a pirate treasure buried there. Nobody has found it. Loads of people have looked, but maybe you're lucky. So I leave that up to you. So 7 major islands and a small one, La Graciosa. And the islands, they are all volcanically active, but more so in the western part. And as I said, there is an age progression. And in this little map down there, let's see whether I can get this to work. Yes, here we have rock ages, radiometric rock ages, and Fuerteventura and Lanzarote, the oldest rocks we have is 20 million years. For Gran Canaria, 14 and a half, about 12 million for Tenerife, and then it gets younger. Gomera is 9 million, and here, these 2 youngsters here, 1.7 million and 1.1 million for El Hierro. So there's an age progression, and it's actually very similar to the Hawaiian Islands. And how does this come about? Well, I'll show you that one rival hypothesis is there's a fracture lying underneath, and the volcanoes might just come up the fracture. We're not entirely sure about that, because if you look at the Azores, and we have a little map up there, the Azores, they sit on fractures, they sit on plate boundaries. All the islands are really long, and there is no age progression, and there's loads of earthquakes. So if you look around, sorry, I'll come here. Here's the plate boundary. It's a triple plate boundary in the central Atlantic. That's where the Azores sit. Loads of earthquakes. So this is out here. But if you go further down, very few earthquakes in the Canaries. So, and some people say there's a connection to the Atlas Mountains here in Morocco, but there's no earthquakes in between connecting them. So I don't think the fractures really work. We have to think about something else. And this is a model that was postulated in the 70s. It still seems to be the best one, and that is the model of mantle plumes. That means we have hot fingers of material that rise up in the mantle, and we have a plate that moves above ever so slightly. And over the millions of years of Earth history, you actually get a chain. It's a bit like a Bunsen burner under the moving Earth crust, and that's also what we believe for Hawaii. If we want to believe that, then, well, how does the plate actually move? And can we see other archipelagos that do the same? And in the bottom right here, there's the Madeira volcanic trend of the volcanoes, even including the submarine ones and the Canary ones, and they both follow a similar trend. We can project it to a pole of rotation. We call this an Euler pole, and this is what happens there. The African plate is rotating around this, and it's moving into Europe ever so gently on a daily basis. So when we look at this, we have now the opportunity to also use seismic waves to look deep into the Earth. And is this true that there's fingers of material coming up? And if you look in the top right, the red colors of this tomography image give you anomalies and materials that are very hot. And there you see under the Canaries, we have this area of redness. It's a little wiggly, but it seems to imply that there's material rising up from very deep inside the Earth. And this leads to a little diagram like this, and this should actually work. It's a little video. Yes, it works. So the idea is that we have a moving plate, and the oldest islands form first, but then the plate moves and takes them away, and then they get eroded, they get shallower and shallower, and then new islands form along the way. And if they are not that old, they might be still tall like Tenerife, and then we have the very youngest islands forming, well, geologically very recently, and that's where the volcanoes are right now. That's where most of the volcanic activity is, because they sit pretty much directly above the heat source. So coming back to how the Earth works inside, in the bottom right, there is an image from the 1600s from Athanasius Kircher, and he had the idea that there was fires inside the Earth and they would come up. We know a little more today, but the Earth still looks like a big mystery to us. On the left-hand side, we have the current understanding. We have an inner and outer core, and they are the heat sources. And then we have the mantle, and there's various anomalies in the mantle. Some of them are mantle plumes that rise up, and here's the one. Sorry, it's very hard to operate this arrow. So here's the one that feeds Hawaii. And, well, down here we have several ones, and these are supposed to be the Canary Islands, the Cape Verdes, and the Madeira archipelago. So then I'm gonna spend a few more minutes on the geological features, and this is the key geological features. And for that, I'm gonna start with this image from Tenerife. This is in the national park, and there we have young lavas that are flowing over old rocks, and this was actually a lava fall, a cascade. So it's like a waterfall, only with lava, and it came over a cliff, this lava flow, and then it was falling down, making these spectacular features. So I'd like to talk about rift zones and giant landslides. I mentioned them earlier. Briefly touch on lava tunnels, and if we have time, I'm going to run you through the recent and historical eruptions of the Canary Islands. Tenerife has this strange shape with three main arms, and the main volcano sits right in the middle. We call these long arms rift zones. And all of the historical eruptions happen along the rift zones. The top right image gives you a flavor. There was eruption 1705, 1706, 1798, and 1909. The lava might flow all the way to the sea, but the eruption centers are usually on the crest of these ridges. And we have these rift zones, not just in the Canaries, we also have them on Hawaii. In the bottom right, you see vent alignments in Hawaii. Actually, the Canary rift zones are better defined than those on Hawaii. So many scientists come here, even from the US, to study how rift zones work. And the old little volcanoes that formed Tenerife, like the old shield volcanoes, Anaga and Teno, they had their own rift zones. So it seems that volcanoes, once they grow to a certain size, they start to have these internal fractures that allow to bring magma up, but very often they also host giant landslides. And this is what the Canaries are famous for. Here's a few impressions. The left one is looking down the rift zone towards the northeast from Teide volcano. And here, now we're looking back from the northeastern end, from the Anaga Peninsula down to Teide. You see the long ridge. It's a bit wiggly, of course, but these rift zones are the main volcanological features of the island. And this is the same, as I said, on La Palma. We have this rift zone, and it's called the Cumbre Vieja, the Old Ridge, as it's locally known. And there we have all the volcanism. So rift zones are the real dangerous part. And, let's go to this one here. And you may have heard about this big threat that was publicized some 20 years ago, that if La Palma has another eruption, it might actually collapse into the sea. And it might produce a giant tsunami, a wave, and the wave could travel all across the Atlantic. And it could actually hit the eastern seaboard of the US. It would be still tens of meters high and it would come with enormous speed. And it all goes back to this particular feature, this crack here on the right. This crack opened up during the 1949 eruption, and geologists started to speculate it could actually have a part of the island collapse away from the main part. Luckily, nothing happened during the 1971 eruption, and again, nothing happened during the 2021 eruption. So we also have instruments there to, well, measure if the flank of the islands is actually moving, and it's not. So we're safe for now, but the reality is these landslides are real. They are giant landslides, and giant means 100 cubic kilometers of material. Let me give you a flavor of this. The eruption of Mount St. Helens in 1980 produced a lava volume of 0.8 cubic kilometers. So this gives you a flavor of the dimension of these landslides. And as I said, this was in the press. This was very big in all sorts of languages when a team of scientists published this around about 2000. And here's the models. So this is the modeling of the tsunami wave if there's a big collapse of La Palma in the top left. And then we have a time stamp here in the top right, 5 minutes, 10 minutes. And then ultimately in the bottom right, after 9 hours, the wave would actually hit Florida. So this is something that's geologically quite realistic, but the probability of such an event is extremely tiny. So that we would see that in our lifetime is highly improbable. So I was there with National Geographic a few years ago, and I told them, this is very, very unlikely. And I said it at least 25 times. But of course, in the final program, it was the worst case scenario is. And yeah, so when you see this documentary, even if I'm talking in there, it's actually very, very unlikely. But it can happen. So then, having seen that, we have many of those landslides on the other islands as well. And I'm gonna run you through a few of them. We have the island of El Hierro, which has these, well, bites. And these are actually landslides. These are large chunks of the islands that fall off. And here's a geological map of El Hierro. Green is again the younger volcanics. And there you see that the youngest volcanics are in these landslide scars in these embayments. So, and this is the El Golfo Valley. It's the youngest of all the landslide scars in the Canary Islands. And it's only about 140,000 years old. So here's an older one, the El Julan landslide. And here is yet another one, the San Andres landslide on El Hierro. And these are beautiful for research, but I would not be actually scared in any way right now. There would be a lot of signs before these landslides reactivate. There would be a lot of earthquakes, and we don't see anything like this right now. So this is the fault line of one of these slides, and there you can really see a steep fault where one mass of rock on the right-hand side was sliding down, and the one on the left was stable. And this is me trying to scale the fracture surface in order to get a sample of glass. Oops. In order to get a sample of glass for age dating. We did get the sample of glass, but the age date didn't turn out very well. So let's look now at Tenerife. Oops. Let's look now in Tenerife. The Las Cañadas caldera in which Teide sits is supposedly also a giant landslide. And there's some debate about this, but recently marine scientists found a giant avalanche of deposits. So the big caldera there may actually had at least part of it collapsing into the sea some 200,000 years ago. If you go to Gran Canaria in the top northwestern cut, there is a bit of a bite in the apple, and on the left-hand image you can see that curved feature, the curved coastline, and that is a Miocene landslide about 10 million years old. And when we go to some of the older islands, then we can still see signs of landslides in these very curved coastlines, which are bays effectively, and that's what we see here even on Fuerteventura, although it's not as obvious anymore. Well, my watch says I have about 7 minutes left, so I'll treat you to some volcanic caves as well. So the Canaries have some of the longest volcano tubes or lava tubes in the world. And if you're really interested, you will have the opportunity to see some in Lanzarote as well as on Tenerife. The image in the top right here is, well, lava sickles, as we call. This is drop stones that actually come from lava. So if there's lava flowing through this tube, then of course the roof gets hot and it can remelt some of the older lava, and then you get these lava drop stones. Geologists love them. And so there is some of these caves that are well over 20 kilometers long, and well, there's some tourist caves, I guess, where you can visit with a guide. But it's almost a sport here on the island for people caving, and every now and then people also get lost and don't come back, unfortunately. But that's what it is. So how do they form? Well, if you have lava flowing, it starts to cool on the surface. It's still hot on the interior. It starts to actually harden at the rims, and you start to make a little, well, a little channel for it, and eventually it's going to overcrust. And it's still going to be runny inside, although it's overcrusted. The images on the right here are from Hawaii, where you see lava flowing underneath, but there's already a crust. And this very brave geologist here on the top right is standing right above flowing lava there. And, well, the lava crust may be that thick or so, but, well, it seems to hold. And here's just an illustration of how this works. We have lava flowing, and the interior then will continue to flow, although the outside solidifies. Every now and then it breaks through as well, through a little skylight, and there you get little tiny cones. We call them hornitos, little ovens. It's a Mexican term, and these are actually very good because they mark lava tunnels that are underground. So when you want to build a house and you see hornitos, it's not a good place to buy. So, and yes, just a few closing words about the lava tunnels. Well, we get a lot of fossils in there because in the old days, 1,000,000 years ago, for example, some animal accidentally ended up in there, died, and there we know that the islands here had a giant canary rat. It was about this size, can you believe it? And it's extinct now, thank God, but it lived in these caves to a certain degree. And some of the local spiders are also going, and they live in these caves. And there, for example, you see the one that's in broad daylight in the bottom there. It's very colorful, and its relative who went into the cave, well, it decided that it's a good idea to be rather invisible in the cave and be black. So it actually turned black. And I remember one of my early cave visits, I was there with this guide, and the guide said, so now we're going to switch off the lights. It's going to be completely, absolutely dark. And I go, yeah, go ahead. And then he switched off the lights. It took about 30 seconds, and somebody was this loud squeak by one of the other people in there. And that lady went with her hands against the wall. And there was loads of black spiders. And of course, the light was switched on again, but yeah, there was a bit of a panic situation for a few moments. So if you ever go into these, be careful with the spiders. They're not super dangerous, but they're not very pleasant, I find. So, closing words. Cesar Manrique, one of the local artists in Lanzarote, he's really famed for working with landscape, and he used some of these lava tunnels to make artworks out of it. So he was big into integration of architecture and landscape, and he made these rather interesting sculptures, like the one in the bottom right, where he built a house and he rearranged the lava in a way that the lava seemed to flow into the house. It's got a bit of a dark side because actually during the 2021 eruption on La Palma, this was a very common feature. And suddenly people were not quite so keen on this piece of art anymore. So, but he built various fancy kind of places, including restaurants in various lava tubes, and he also built a ball area, so you can go dancing there inside a lava tube, and there's even a concert hall inside the lava tube. So, with my remaining 2 minutes, I just gonna show you this slide here, and this is about the active historical volcanic eruptions on the island. The image on the right-hand side is a few of my colleagues and myself in front of the 2021 eruption. The image in the top left was the 1971 eruption, and the night image is from 2021. In the little diagram underneath, we have historical eruptions on Tenerife, on La Palma, and on Lanzarote. We have recent eruptions, recent meaning geologically recent in the few thousand years before present, but not recorded or witnessed. We have them on Gran Canaria and El Hierro, and Fuerteventura and La Gomera actually have the lowest historical volcanic record. So during the 21 eruption, a lot of people ask me, Val, where do we need to go to be safe from volcanoes? And that's the answer. You can go to Fuerteventura and La Gomera. But none of the islands is truly safe from volcanoes because they're all volcanic in origin. Thank you for your attention.